Hi, pre-calculus students. In this video, we are going to look at section 8.2, some of these nasty graphing problems. If we start with question 1, you can see it says determine the equation for the trigonometric function below. Looking at this function, we know it's either cosecant or secant. And let's talk about why. I'm going to share a screen here. Here you see the graph of secant, which roughly resembles the graph that we have there. So it could be secant, but it could also be cosecant. Oops. Which looks very similar to the graph we have there too. So we have to analyze our graph and determine which it is. Now, cosecant is really the reciprocal of sine. So here I've graphed y equals sine x. And you can see that when y equals sine x, sine starts at the point 0, 0, and then comes back down and hits 0 at pi units on the x-axis, and 2 pi units on the x-axis, and a negative pi and negative 2 pi. So this is cosecant. If we changed it to secant, back to secant, that is the reciprocal of the cosine function. So it has the cosecant function touches the cosine function at 0, 1, but it passes through the x-axis at pi over 2 and 3 pi over 2 and negative versions of that. So we can use either one of these, but what we do know is that it is a secant function or a cosecant function. Let's say it's a secant function here. Let's go with secant. Secant starts with a vertex here at 0, 1. So what we need to do is figure out where this vertex has moved, and that'll give us some of our translations. So let's go back to that graph. Let's make sure I have it on there. Yep. So here, the vertex, which was at 0, 1, has been moved over, it looks like pi over 8 units to the right and up a few units. However, we also need to understand that the midline here is not the x-axis, but the line y equals 2. So this, whatever this graph is, it has been moved up 2 units. So at the end of our translation function, we're going to have plus 2. I'm going to start this on a whiteboard. So what we had been saying is that the midline of our graph, I tried to graph that here and so that we could write while we were graphing, but the midline of our graph had been at y equals 2. So instead of it being at y equals 0, it was shifted up 2, and that's going to be reflected here because the vertical shift is the number being added to the function at the end of the function that's not in the argument. Now, when we look at our horizontal shift, we had said that typically, I'm going to draw this in here in a really strange color. How about an ice blue? Typically, the secant function would do this. So its vertex would have been here. Now, it's been vertically stretched and scooted over to the right and moved up 2. Well, how much has it been vertically stretched? If we look at the distance from the vertex to the midline, that's usually 1 on the regular secant function. But here, from 4.5 to 2, it's been vertically stretched 2.5 units. So our amplitude here is 2.5. We'll just call that 2.5. So that goes in here. All right, now we're going to figure how the period has been shifted. The period on the secant function is 2 pi. 2 pi is usually the period. And the number we put in here affects the period by being the 2 pi divided by that number. So that's not a whole period on this. Excuse me, I didn't mean to draw that. A whole period on this is going to take us from one peak to the other peak. So it's going from back here to right there to that. So back here, I'm at between a negative pi over 4 and a negative pi over 2. And to split the distance between those two, we'd be at a negative 3 pi over 8. How do you know? Add them together and divide by 2. You'll get a negative 3 pi over 8. Here, similarly, to get to the other side of our period, we are at between pi over 2 and 3 pi over 4. So halfway between pi over 2 and 3 pi over 4, if you add them together and divide by 2, you're going to get 5 pi over 8. So we're going from a negative 3 pi over 8 to 5 pi over 8. To find that width, you subtract them. So 5 pi over 8 minus a negative 3 pi over 8 is going to give us 8 pi over 8, or pi. So our actual period here from a negative 3 pi over 8 to a positive 5 pi over 8 is pi. So we're going to stick that into our formula here, and we'll say pi would equal 2 pi over k. Solving this isn't hard. We can see that if k were 2, you'd have 2 pi over 2, which would equal pi. So k equals 2, and that's the number that goes in here. All right, we're getting there. Now we just need to identify how far over to the right this function has shifted. So this function, usually we are at 0, 1, but now it's shifted. The vertex has shifted to the right pi over 8 units. So this h is going to be pi over 8. Now, if you move to the right, it's minus pi over 8. And if we had moved to the left, it'd be plus pi over 8. But we did indeed move to the right. So let's plug this in to our derivative and see how we did. So you can see that we plugged it in here and we got the right answer. I will, if you have problems plugging it in, let me know, and we'll look at another problem in another video. Thanks for watching.